Good morning, everyone. This is Bill Gentz with TopSolid USA. I'm the Sales and Technical Director for USA Operations with the TopSolid product line. In today's webinar, we're going to take a focused look at programming parts specifically for job shop style programming. And I'm going to try to give you guys an idea of different ways you can work within the TopSolid solution. If during the presentation any of you have any questions, feel free to type them into the question section and we'll try to answer as many of them as we can at the end of the presentation. The presentation should last about 30 minutes, maybe a little bit more, depends how detailed we start getting into things. So here we go. So in the world of job shop programming, sometimes you need to work quickly. I'll call it down and dirty even, where someone just comes in and says, I have this plate, I need to cut a few pockets in it, poke some holes in it. And you don't want to screw around, you just want to get that machine running, because when the machine's running, you can go ahead and make money. So let's have a look at what I mean. If I go into my project here, I have our first sample here is called Down and Dirty. I'm going to open it up and just show you what I'm talking about. So here I have a couple of basic profiles created. I have a rectangle where I'm machining off the face. I have pocketing operation 1, open pocketing operation 2. Quite simple. What I'm going to do is show you how you get there. That's the important part. One of the things I really like to do when I'm showing TopSolid is I don't want to hide anything from people during demonstrations. I want to show you click by click how we do it. And then you can be the judge. You can decide whether or not this is more efficient than what you're doing now. So here's how we're going to start. I'm going to go to my demo folder here for Down and Dirty. I'm going to right click on it and I'm going to choose to make a machining document. When I do that, the software is going to ask me what template do I want to use, and we're going to get into some of these more advanced templates later on in the presentation. But for now, what we're going to do is just work with a basic mill, because again, at the end of the day, the goal of this is fast. So we're going to call this, it's going to ask me what to name it here, so we're going to call this plate. Why not? So right off the bat, you see a plane, you see some axes that represent the machine axes, and you see where our G54 is. Our G54 is right here in the center. Now we can draw about that, and that'll be fine, or we can draw whatever we need to draw and move our G54 to where we need it to be. Choice is yours. For this sample, I'm just going to draw about my G54, so I'm going to go ahead and go to Cad Mode. In Cad Mode, I can either right-click and start a sketch, I can go to my 2D Sketch tab up here, hit my pencil to start a sketch, or go directly to the command that I want to use to start the sketch. Again, choice is yours. Here, I know that I want to create, for example, an 8-inch by 4-inch rectangle. Now, if you look at my rectangle, it's following my cursor around the screen based on the center point, which is convenient because I want that centered about 0, 0. Perfect. So I now have the boundary of the plate that I'm machining. Next, I want to create another sketch. In this case, it's going to be another rectangle, and I want this rectangle to be 2.5 inches by 2.5 inches, again, by the center. And I'm going to pop it right on my x-axis there. This way, we know where its location is up and down. And now I'm going to add a quick dimension from here to here because the guy that I'm building this for said that's a 1/2 inch from my 0. Last thing I'm going to do, I'm going to add some quick fillets in here, maybe 275, whatever. You get the idea. I have my geometry. Now, at this point, we have enough. Let's go ahead and start building some toolpath. So now, when I go into TopSolid, or when I switch back to TopSolid Cam, just to illustrate again, this is just flat 2D dumb geometry. There's no intelligence here. So, to begin with, I'm going to simply select what I want to machine, right-click and go to End Milling. Or, again, if you're new to the TopSolid interface and you don't like right-click menus, you can go to the 2D, 3D tab and click End Milling right there. For those of you that don't know, End Milling is a combination of facing, pocketing, and open pocketing. It's all in one command. It works on profiles, it works on solids. You'll see it works pretty much across the board everywhere. It's wonderful. Now here, the software chose for me my face mill. It's the first operation, kind of makes sense, so it's grabbing my face mill. Now, what you don't know is the template that I chose, that basic mill. I have my favorite tools already loaded in the carousel, and we'll get to that in a second too. So right off the bat, it found the area to machine, but we have a problem. Notice here there's an asterisk, and if you hover on it, it's telling you the starting altitude is got a problem, the final altitude, the rapid planes, because it's just 2D curves. The software cannot make intelligent decisions here, not with data like this. So here, if I say my starting altitude is going to be an 1/8 inch above 0, maybe in my mind I know I have an 1/8 inch of material to remove, right? And then if I go down here to my rapid planes, I want a rapid, not at 21 inches, at 1 inch. Clearance altitude between regions is 1 inch, and final altitude is 1 inch. Now I have toolpath. Now here, because TopSolid really is intended to work off 3D models, I'm also going to go turn off a default command called ZPath stock fitting, which we're going to come back and talk about in a little bit. And now I want to treat this as a facing. Remember I said they're all in there. You can just choose what you want. And now we have our facing. If you notice, the depth of cut is being calculated based on the starting altitude that we set, and the depth here per pass for this tool is being calculated based on a default value. I'm telling it to take 10% of the effective flute length of my tool. Cool. Green check. I have my first level of toolpath. Let's keep going. I want to select this profile, go to end milling, but in this case, that tool is too big. So let's start by switching tools. And here's what I was talking about where I said I have some defaults in here. Notice I have a bunch of different types of tools in here. Maybe for this operation, I want to use my 1/2 inch end mill. Cool. Like before, it's still missing the starting altitude, the ending altitude, everything. So let's go to altitudes and say our starting altitude is 0 because we just machined to there. You're the one having to remember where these altitudes are, by the way, because you're just using dumb curves. And we want to machine to a value of -0.5. Now we don't see any toolpath yet because we still need to tell it the rapid altitudes. We'll go here, and now we have toolpath once more. Perfect. Now that's all fine and dandy. This is showing you fast ways to work, and I can go into here and I can run verify on this, and the software will throw kind of a just make-believe stock model in there so you can see the material removal. That's great. Everything looks like it's supposed to. But can we make it a little bit more intelligent? Well, the answer is yes. Let's say we have one more feature to cut into this quick plate, this job that we're doing for customer XYZ. Well, what you can do, I'm going to start my sketch. Instead of drawing everything at the same altitude or the same plane, I'm going to tell the software, you know what? I'd like to go and offset my starting plane down in Z some value. I want to offset it to the depth this pocket is actually going to go to. Okay? And then I'm going to make my sketch. We'll look straight at it here. And this one is going to show off how to do an open pocket. Why not? Okay, so we're going to close that up like so. Let's go ahead and add some quick dimensions. Maybe I want this to be like this. It's going to be a 1/2 inch. And basically the steps I'm taking, I'm going to show you how to do something similar to this directly from a 3D model. That's coming up here in a few minutes. So here, let's say that I want this to be 3/8 from my 0. Let's say we want this to be a 1/16. You guys get the idea. I'm just basically giving this the size that my customer told me it needs to be. Great. Maybe I want to add some fillets in here as well. So let's go here and say we want our 275 fillets on all inside corners. And then we want a 30 thousandths edge break on that outside corner. Good enough. So now we have that profile. We switch back to machining. And when we're in machining now, I'm going to select this. And one thing is going to change, the altitude. Notice it knows that that's where we're machining to now. And it's because we took the time when we made this sketch to be down to that altitude. So now if I go to my settings, again, same concept as before. I want to go to my altitudes. My starting altitude is going to be 0. My rapid planes, I'm going to have them all at 1. You have different rapid plane choices here. I'm kind of blowing past them, but this is your general clearance altitude. If I was machining both pockets in the same operation, this is the altitude between those when the tool moves back and forth. And then when we're done with this operation, where do I want to retract the tool to? That's what that's all about. Now here, this is treating this as an open pocket, as a pocket. And that's because it's a closed boundary, right? There's no solid, there's no stock, there's no nothing. The software doesn't know and cannot make any intelligent decisions for you. And again, I'm going to come back to those intelligent decisions. So here you have to tell the software. So here I'm going to say, you know what, treat that as an open pocket. And our toolpath goes away. Why? Well, it goes away because we have to help TopSolid and tell it where the pocket is open. So we go to geometry, go to our open zone, and we can say, for example, it's open right there. Just select the segment or segments where it's open. And now you can see it extends the toolpath out appropriately. And like that, I've now created the 3 main pocketing operations that I need to make. Okay? Now, I could continue from here. I could go through and I could go make side millings. Side millings are like end millings. The only difference is you're finishing profiles. Maybe we want to change the tool. Let's go here to 3/8 for just 4. I didn't talk about speeds and feeds, so let's talk about them really fast here. TopSolid will pay attention and learn from you as you go, so it will remember common speeds and feeds for tools, tool types, material types, specific machines, but you can always come in and override. You can say, you know what, I want to run this at 2,500 inches a minute or 2,500 RPM at 25 inches a minute, or maybe you're a surface foot person. I want this to be 425 surface feet and I want a 5,000 ship load. You can see one updates the other and vice versa. You choose your coolant method that you want, off you go. Now, just like with end milling on profiles, when there's no solids, no stock, no anything, the software does not know what you want to do. So we have to go to our altitudes. We set our starting altitude. We come here, we set our ending altitude, right? So we go to value and we'd say minus 0.5 from our G54. We set our rapids. Nice. Okay, and now we have our toolpath. And we can choose where we want to start and end the toolpath. You have everything that you need. Okay, so that is down and dirty programming. And if I go into TopSolid's post processors and I go to generate ISO code, for example, I'm going to go into here and I'm just going to choose a simple little Haas mill. We'll post process. There's your G code. Little tool setup sheet, G code. We're rocking. You're out running in a few minutes. I've spent a whopping 10 minutes programming this. If I wasn't talking and just focused on the job at hand, this is a 2 to 3 minute job. Not a big deal. Maybe 5 minutes. Okay. Now, where I want to go to next is how, as a job shop, can you program more efficiently? Well, you use modern software. What I just showed you is the fact that TopSolid is capable of programming like all the other CAM solutions. We can take simple profiles, you can throw a toolpath on it, you can make all the manual decisions you want to make. Or you can use a software that's written to be just a little bit more intelligent out of the box. What do I mean? Well, let's begin working with some 3D models. For example, if I go to working with 3D data, I have a sample called create the model and a sample called import the model. I'm going to show you both. If I go to the create a model and I go look at the machining side of it, here notice that same plate we were just describing, I have it described as a solid model. And I have my toolpath for said solid model. Okay? How? Well, let's take a look. I'm going to go into my demo folder and I'm going to create a part first this time. What you should have noticed before, and we'll just call this sample part, what you should have noticed before, when I was in machining in my down and dirty sample, I was just going and building a sketch, right? Well, I'm halfway through to the solid model when I'm doing that. So if I go to part mode and I start a sketch, I can go to my rectangle and I can build that same rectangle. I want an 8-inch, what was it, by 4-inch rectangle right here. What do I want to do with that rectangle? Well, I can right click, TopSolid will propose the option. I can go to the Shape tab. Only options that you can use are currently lit up, so the interface is always helping you out. So I'm going to extrude this, and we'll extrude it up, doesn't matter, up, down, and I'm going to say 875, perfect. Now, on this top face, I'm going to create another sketch. Look straight at it again, just so it's easy to see, and let's go make that 2.5 by 2.5 rectangle. Again, I'm taking very, very similar steps to what we did. I'm just adding the modeling steps in between, and maybe this is supposed to be a 1/2 inch. Good enough. And here, I want to cut a pocket. Now notice this time I skipped the fillets. Why? Because when I add my pocket, maybe my pocket is going to go down a 1/2 inch, I can add fillets in the corners automatically. Nice. Let's go add our open pocket. So I'll go to sketch again, look straight at it. This time I'm just going to sketch it out just like you saw me do before. I'm just adding my segments that I want. I'm always creating my closed sketch. And I'm going to add my dimensions. So I want a dimension from there to there. That's supposed to be a 1/2 inch. I'm going to dimension from here to here. I'm too lazy to type the value in, so I can click here and get from any of my previous values that I've typed in recently. Nice. If I add my dimension from here to here, maybe I don't want to click on that. Maybe I just want to borrow this value. I can just click it and it fills in the value. No matter how you want to work, you can work. Maybe you need to do some math here and you're too lazy to get out your calculator and you're not very good at math. I want this to be 0.937 1/2 plus 0.187 1/2. Cool, there's my inch and an eighth. And notice it leaves the equation there, so when you come back later and say, where the heck did I come up with that number? There you go. Now I'm going to add my fillets, because here I have inside-outside fillets that are kind of custom. I want my 30 thousandths fillet there, and then I want a, what did they say, 275 on the other corner. So you can select near the corners on the vertex. The choice is yours. This time when I go to pocket, we're going to go to a different altitude, and we're going to turn off that. I'm going to say that's to 3/8, just to be different. So now we have our 3D geometry, right? And because we have our 3D geometry, now it's time to process said geometry. So let's go here, go to machining. We're going to send this simple part to machining on that basic mill. And when we do, TopSolid is going to automatically create the stock blank for us. Now my default settings, I have the stock set to be an 1/8 inch per side. Okay, perfect. We'll just go ahead and validate. My G54 is at the top center of finish because that's where I like it. Again, it's a default settings. But now you have a clear understanding of what it is you're going to machine. So to start with, we want to face this off. So let's select it, go to end milling. Now, if you remember from the 2D side, I had a lot of things to do. But here, because I took the few minutes it took to get the 3D model drawn, TopSolid can automatically determine the starting altitude, can automatically determine the ending altitude, and can automatically determine the type of machining it is. That's a facing. All I need to do is click OK, because it's using, again, my default settings, my company knowledge, with my fees and speeds, with my depth of cuts, everything. And it's updating that stock condition. Let's go do our pocket. Now, if we go to do our pocket with that big tool, it's going to look and it's going to say, hey, yeah, that's great, but you know what? I can't really fit that tool in there, can I? It's really trying, but no, tool's too big. No big deal. Let's go here and let's pick a different tool. Maybe here I want to use my 1/2 inch end mill. What's cool about it is as soon as you change, check it out. It made the tool path. It's set the right starting altitude, the right rapids. It's helically entering. It's doing everything it's supposed to, because when you use the solid models of the finish and the stock, TopSolid can make really intelligent decisions for you. Awesome. Now, something else about using intelligence. This toolpath worked really well here. I'll bet you it works the same over here, right? Wouldn't it be cool if you could just control, drag, and drop a copy of that toolpath over to that face? And we thought so too. The only difference is, notice it automatically found that as an open pocket. I didn't have to go and tell it. So I'm processing parts more quickly with my company knowledge being applied dynamically, getting to that finish line faster than ever before. Now, let's go ahead and just do some quick finishings. I'm going to control select the Z altitudes I want to machine. I'm going to go to end milling. Maybe we want a different tool for this, right? Why not? Let's go to our 3/8 tool. Who knows? So I'm going to use that tool. Now here you still don't see any tool path, and that's because there's still stock to leave on the floor. Watch what happens. I'm going to set that to 0. And now the software again is going to make really, really intelligent decisions. It's machining everywhere there's material. So if you look at that top altitude, notice it's not cutting air above the pockets because it knows where the material is. The other one, in my pocket, notice it's helically entering, but just starting above the material there. We don't need to helical enter from 3 feet above the part like a lot of softwares do. And over here, because it's an open pocket, just plunging in air, nibbling its way in and out. Fast, efficient, getting to the finish line faster. And if you get your machines running faster, in theory, you should be making more money because you can process more jobs. And after all, that's why you're in the business you're in. Let's finish this by going to side milling. If I go to side milling, here the software is going to do what it needs to do. That's perfect. Just to show you in the same operation, you can mix and match. But now here's something interesting happens. When I go to side milling, it's a finishing operation. It's going to go to the lowest Z of the face selected, and it's going to find everywhere it can that there's material. And notice it's wrapping around the outside of the part. That's because technically I have material there. But let's say, again, you don't want to machine there because you want to do that with a different op. You can come in here and say, you know what, machine the local feature only. So you're always in the driver's seat, even when you want to disagree with the automation that TopSolid is applying. Now that's done. That's as far as we need to take this right now. So let's maybe quickly run through verify. I want to make sure that this is good. So you can see it's banging through, and I have it running at a pretty fast mode because, again, short little webinar. Everything is good. I can go here and check for comparison. Green is good, blue is material. Anything that looks like it's bleeding would be a gouge. So that's kind of awesome. Okay. The last thing I want to do, pardon me, is I need to document my work, right? Because I got to send this out to the floor and my operator needs to know what the heck's going on. So wouldn't it be awesome if you could just simply and efficiently create a setup sheet? And what I'm about to show you is out of the box. I can say operations with drawings. When I do this, check it out. The software is going to document everything for you. The creation date, the name of the CAM file, the name of the tool number it's in, the diameter of the tool, the shank distance, the feeds and speeds, pictures of everything, where the G54 is located and what its orientation is. And oh, by the way, we did this for every single operation automatically. What's even cooler about this is a TopSolid drafting document, which means if there were critical dimensions that you want your guy on the floor to check, go and add them here. This way he knows, if he sees the dimension on the print, to go and measure those features. Kind of nice. Now, let's close that and let's keep this discussion going. Because what we did there is we drew the part. Because your customer, they gave you a PDF file or a hand drawing or something like that. Now we want to kick it up another level because sometimes, maybe quite often in your business, customers send you the 3D model. So you can skip the whole design portion of it. Cool. So guess what we're going to do? We're going to import a model. Now, in here, I have a model imported already. Kind of looks like that. Just to show you, anywhere you see a preview image in TopSolid, if you middle click, you can go into live preview. So that's the part we're going to look at cutting next. It's kind of fun. I made two different operations for it because technically you have to machine it from two sides. So we're going to take a look at doing that together. So I'm going to go to my demo folder. And here, we're going to go ahead and just start by converting the data. Now, this is just a Parasolid file, but just to show you, I'm going to do the conversion a different way. I'm going to say import file with conversion. And just to show you quickly what we can read, if I zoom up here, we read everybody. And I truly mean everybody. We can read data from most softwares on the planet, most CAD softwares, let's qualify that, on the planet. Some of these translators are extra, I will tell you that. CATIA, ProE, and Unigraphics are add-on translators. I believe everything else is standard in the solution. So we read SolidWorks, Solid Edge, Inventor automatically. We even read Google SketchUp because we can. We read, like I said, a lot. So what we're going to do, we're going to convert this file. So I'm going to right-click on that file and choose Convert. And from here, we're going to do a couple things. We're going to go ahead and convert this. The software is going to convert that Parasolid file into TopSolid design file. We're going to quickly run through a check on it. This is a healing wizard, and what this does is this makes sure that the part imported cleanly with no problems, and everything is perfect, so life is good. And because it's a webinar, and it's a short webinar, and we have just a handful of minutes left, you know, of course, everything's perfect. But we want to process this part. So now what we're going to do is we're going to do all the steps. Instead of going straight to machining, I'm going to choose Machine Part Setup. When I choose Machine Part Setup, this is an intermediate document that lets me choose how I want the material to be. Okay? Maybe in the first operation, I'm going to hold it upside down like this in a vise. Okay? Why not? So I'm adding a little bit extra stock down there so I have something to hold on to. From there, I'll leave an 1/8 inch everywhere else. That's pretty good. And then we'll hit our green check. Our stock is now ready. Next, what I want to do is I want to send this into a machining file. Now, in the first few samples, I've just been using this basic mill. Okay, and this basic mill is just a generic 3-axis anybody mill. Now, I want to put this on my Haas VF6 or on my Kitamura or whatever machine you may have. So I have a template here called Haas VF6, and I have a vise in there. So watch what happens. When I click OK, it's going to load me into my template. Okay, it's going to ask me how I want my stock to be. I'm going to choose exact for now. And if you look, I actually have my Haas VF6, and I have my fancy table. Now, let's go ahead and look at that one more time, because this is really, really cool. I'm going to cancel that. I'm going to look at it one more quick time. I'm going to go here, go to machining, choose my template, and my entire setup is actually already preloaded in the document. Okay, that's pretty unbelievable. Now, what we're going to do next is we're going to load this onto the vise. So I'm going to go here. I'm going to pop that in right there. I'm going to take this face here and I'm going to lock it to the vise there. Part's pretty big, but that's okay. We want to center this on the vise maybe. So what I'm going to do here is let's just go to a midplane between this face and this face. And let's pop that to another midplane between here and here roughly. Again, not too worried about it. Maybe we have a bump stop that we hit it up against too, and you're good. Let's put that back, okay? Now, here, to simplify my view, I'm going to go into the display. I'm going to turn off my ground elements, my enclosure. This way we can see the machine, the vise, everything else, but we're not worried about the enclosure. So everything else in the environment, or the program environment, is the same. The only difference is we have the full machine. And the reason we have the machine, just briefly, is this way we know the kinematic capability of the machine. It can travel so far in Y, it can travel so far in X, and if we over travel that or we run into something, the software is going to yell at us. Because it's better to know that we caused a collision here or an over travel here than spend a lot of time programming the part, loading it on the machine, only to find out, well, damn, I guess that doesn't work, and we have to start over. So let's get started. So we have the part loaded. I want a machine. Just like you saw before, I can go to end milling. Select my face. It's going to grab my face mill first because it makes sense, because it's going to be facing. Okay, but you know what? I can change my mind. I can say, you know what? I don't like that. I can come into here and say, you know what? I just want my 1-inch roughing end mill. I like that better. Okay, maybe the reason I like that better is because, you know what? I don't even want that face. Maybe I want to start lower. So I'm going to go here and start at this face. But what you're seeing is in real time, I can select things and see how it affects it. Now here, that's technically an open pocket feature, so the software is seeing that as an open pocket feature. I'm going to say, you know what? Let's go ahead and let's treat that as a facing. And now notice it's grabbing everything, including that top altitude, because it sees that as an island. Awesome. So now I've roughed down to that level. Next, I want to continue roughing, and I want to rough down below this level. Okay? But to make things simpler, I'm going to hide that, and I'm going to switch to Cad mode, because here I need to manufacture something that's kind of sort of to net shape, but needs a little help. So now I'm going to use a mixture of curves as well as solids. So I have made a sketch on that bottom face. I'm going to go make a rectangle, and this one is going to be super duper accurate. And by super duper accurate, I mean I'm just going to draw a little rectangle, because I'm just defining the area I want to machine to. Now watch what happens, and we'll turn the machine back on so everyone doesn't get lost. I'm going to go here. I'm going to copy this same toolpath and paste it. And this time, instead of drag and drop, I just did Control-C, Control-V. And the reason I did that is because I want to make a change. I don't want to machine there. I want to machine to this profile. And now what's going to happen is it's going to calculate everywhere that needs to be machined inside that profile. And I'm done. But what you're noticing is that I am going back and forth between solids-based, curve-based. I'm using machine simulation. Oh, speaking of machine simulation, let's actually simulate what just happened. Let's actually turn the spindle on even so it's spinning, because it's more fun when the tool spins, right? We can go ahead and do that. And you can check for collisions. You can check for everything. Everything is in real time as much as possible in TopSolid. Whereas in competitive products that may or may not have machine simulation is an afterthought. Sometimes it's an extra module you have to purchase. It's kind of hard to set up and configure in TopSolid. It's a click. That's all you need. So if it's a click, you're likely to use it. Let's keep on machining. Again, to simplify, I can turn the machine off. What about machining here, and here, and here? You know what I'd like to do? I would like to take and machine some plunge holes. So I'm going to come in here. Notice I control selected geometry this time. They're all different diameters. I'm going to say, you know what? I don't really care. I'm going to come here. I have a 1/2-inch drill in my carousel by default. Good enough for me. And I'm going to drill that. And they're all going from different starting altitudes to different depths even, because I just want to drill them. Why do I want to drill them? Because now I can mill them using hole machining. Now, hole machining doesn't necessarily mean drilling, tapping, reaming, boring. Hole machining can also mean end milling or side milling. For example, I'm going to go to pocketing inside of hole machining, and I'm going to go pick an end mill. Let's go grab a 1/2-inch tool or a 3/8 tool. It's probably better because this way we're not rubbing on that pre-drilled hole. And now I'm going to pick my geometries. Check it out. I'm going to go here. I'm going to go there, and I'm going to go there. All of them at different altitudes, all of them automatically plunging at that pre-drilled location and nibbling outwards. And of course, you have full control over depth of cut, XY step over, stock to leave, everything. But what you didn't have to do is remember where all these start altitudes were. You could just process the part the way you're thinking naturally to process the part. Another fun point, this was a blind depth pocket, right? These were through holes. Notice this operation went beyond, because it's a through hole, automatically. I didn't have to tell it to. Pretty awesome. Let's finish this stuff up and then we can flip this part over to Op 2. So if I go here, again, I'm going to machine these just like I did before. I'm going to go here. I'll go to end milling. We're going to go ahead and maybe I'm going to change my tool now. For my finisher, I want to use my 1/2" end mill to finish the floors. I want to stay maybe 30 thousandths off the walls and go to 0. Cool. Done. Tool path finished. Let's turn that off. So if we zoom way up, you can see the stock to leave here. There's stock to leave on the walls. So let's process those as well. So I'm going to start here and I'm going to go to side milling. Maybe for this one, maybe it's a really, really rough material and you don't want to bury the tool and just walk into it in one step, and you don't want to pick up in rapid between Z levels. You just want to stay in a constant cut motion. So what we could do is this. I'm going to come into my full settings for the first time in this demo, really, make a change. And I'm going to say I want a 30 thousandths depth of cut. You'll understand in a sec. If I do that, you're going to see the preview here pop up. So we're taking a shallow depth of cut because, again, accuracy, whatever. But instead of picking up and rapiding, I'm going to activate helical mode. And what you just saw is the software just switched to a constant helix. This way the tool stays engaged and just spins down the part. Kind of awesome. I could mix and match that. I can say, you know what? I want to do the same thing over here. And I want to do the same thing over here. Or maybe you wanted to use a boring bar on that. I mean, the choice is really yours. Okay, and then you have your preview there. Now we're nearly done with setup 1, and I'm going to show you how we flip this to deal with Op 2. And we're about half an hour into this, probably going to use about 10 more minutes here, so thank you for your patience. Here we go. So what I want to do, I have a choice. Do I want to machine this face all the way around, or do I want to machine this face by itself, this altitude by itself, and then machine this final profile by itself? Well, let's show you what I mean. If I go here to side milling, okay? So by default, and I'm going to set this to 1 pass because that's all I need. By default, again, you see how it's going all the way around the model. I could say, you know what? Let's look at the local feature and see what it does. It trims it up just to that local feature. And I can do the same thing over here. That's going to go around. So we have to go to its balloon, local feature. Perfect. And then I could select this face here and check it out. That's going to go all the way around the part perfectly. Now I'm doing 1" depth of cuts. I could do 1/2" depth of cuts. You could do whatever you want, control it however you want. But at the end of the day, we have now finished our part without thinking hard. The last thing I want to do, customer says I need to break all the edges, so let's do that. And this is so much simpler because it's a solid model. Yes, I have a chamfer command, but notice there's no chamfers on the part, so I'm going to go to break edges milling instead. Here I grabbed a spot drill. It could be a chamfer mill, it could be whatever. I'm going to go to here, and I'm just going to have it find every edge that's machinable. There they all are, and I'll just say go. Now, what's really awesome here, if you look at the chamfers were put on uniformly everywhere, except where they might collide. So if you look, this chamfer stops here long before the tool ran into this wall. And if we go and verify just the chamfer, yes, you can verify just one object in TopSolid. That's pretty awesome. And verify can be with material removal, with machine simulation. There you go. So here we have that. We're going to wrap it around, do that one. I'm going to pause this when we get down to the next altitude, and we have to stop the tool appropriate. Here's that. Okay, let's come around. I'm going to stop this, and I'm going to slow this way down. We'll zoom up. So you'll see, okay, don't have to go that slow. It's coming, and it stopped. Notice it's already picked up. It's already off the part here. I didn't have to tell it to do any of that. I didn't have to figure out any of that. The software can make intelligent decisions for you because frankly, that's what softwares are supposed to do, especially in today's world. Okay, there I made a mistake, right? So that would have snapped our tool, but now we know, so we can go back and edit. Now I could go into my geometry and I can go find which is the right one, right? It's that one right there. I could delete it. Or I could set a limit down here and say, you know what? Any circle with the hole diameter that is whatever, don't do. It's up to you. But now I've resolved that problem, and off we go. Now we're done with Op 10. Okay, I'm going to come over here to my operations manager here, or my my file manager. I'm going to call this Op 10 because that's what it is. And now what I want to do is I want to reposition this into another machining document because I have two machines that I'm running this on. One machine is running Op 10, the other machine is running Op 20. So we're going to do that. I'm going to send it back into a VF4 with vise, but maybe I won't use the vise this time. Okay, so I'm going to go here. What I want you to pay attention to when I reposition is this. Let me pull it off to the side here. What do you notice? The updated stock model came with, didn't it? So I can say maybe I know I have a fixture plate that's on here. I'm not worried about colliding with it, so I'm just going to position some things like so. And let's go ahead and align this with this. That squares it up to the table. Sure. Whoops. See, even demo guys make mistakes. Let's try that one more time. With that, there you go. Validate our positioning, and off we go. I can go ahead and go to my display, and I can hide that enclosure again. I can go hide the vise. It doesn't really matter. Okay? We can go to our entities here, and we can go find the vise. There's that, there's that. Boom and boom. Anyway, everybody gets the idea. Oh, there it is. Where is it? That's the main assembly. That's what I'm looking for. Okay, so sit down a fixture plate. Now we want to continue machining. Now, one of the things that's kind of cool about TopSolid is the ability to reuse things. For example, I can go back to Op 10 and I can say, you know what? In Op 10, that first facing I did, that was really cool. That worked really well. You know what I want to do? I want to copy that. And I'm going to come over here to my next file, which I should be labeling Op 20, excuse me. Let's fix that. Everything's always editable. And I can come in here and I can do paste. And then the software is saying, do you also want to copy the cutting conditions? Sure, why not? And now it's showing me the part. I can rotate, pan, and zoom with it. I can look at it. Okay, I want to machine down to that altitude and hit go. And now it's copying every change, every setting, everything over to this new geometry, new file even, and it's applying it. Let's rebuild. And like that, facing is done. Now, something cool about that, besides the fact of how simple it was. Notice how TopSolid is paying attention to the part. I'm using a regular square end mill. There's a fillet down here. TopSolid recognized that fillet, and instead of blowing it away, it stepped out and around it appropriately. You didn't have to tell it to do this. Huge difference between us and most platforms on the market today. Again, we can use that same drag and drop technology. Let's go here. That's going to machine down that altitude next. If I go and modify that one, because truthfully I can probably do the other one at the same time, let's go there. But again, the thing I want you guys to take away from today is how quickly and efficiently we are programming parts in TopSolid. No matter if it's a down and dirty project, something you just got to bang out quick, hey, profile this, cut this, move on with life, all the way through processing something in a pre-production to production style toolpath. It's done quickly. Now, let's say we have no idea how big that radius is, but we want to machine that. Okay, let's go ask TopSolid. I'm going to go in here to Analyze, go to Measure, and let's go select the face. It's going to come up and tell me what it is. It's an 1/8 inch radius. Cool. So let's machine it. Here's what I'm going to do. I'm going to go to end milling on here. And I'm going to go build a new tool because all my tools right now are just regular end mills. Thus far, I've not shown you how to build or create or load new tools. So in this sample, I'm going to build a new tool. It's going to be a radius mill. If we look, here's a preview and you can see the radius on it. I'm going to say this radius needs to be an 1/8 inch. Maybe the diameter is going to be 5/8. Let's have a look at that. Yeah, that looks nice. Maybe it's got an inch of flute. Is that enough flute? No, we should probably go with the 1.25 inches just so we get better finish. Perfect. Overall length of this tool is 3.5. You get the idea. If I come into here, I can say, you know what, this is a special 5 flute cutter. It's good for cutting widgets. I can go to my tool assembly. I can play with my gauge distance of my tool. I can have it short and stubby. I can have it sticking out a mile so we get good tool flex. You can do whatever you want. I'm going to say let's make this 1 3/8 just so it's a good round number. That's as good a starting point as any. So now we have this tool. That's fine. I'm going to set my stock to leave on the floor to 0. Okay? And what you're going to see is it's going to machine everything the way it's supposed to machine everything. And it's going to get that tool as close as it can, leaving 10 thousandths on the wall because that's what it's set to. Notice it's paying attention that the tool can fit now. That's awesome. Now, maybe you don't want to rub the side of this tool on the wall, on the rough wall. So let's go here. Let's make that 20 thousandths. So that's going to step out a little bit. And let's set this to be a facing. This way we machine both sides right away. One last thing. If you're really set in a production environment, rapiding up to this altitude for everything, that's a waste of time. Let's go into settings and make a change. If I go to my altitudes, I can do retract if necessary. And what just happened? The software is retracting as high as it needs to, only if a collision is detected. Pretty smart. Again, able to use the 3D environments in real time. That's really cool. Now, let's do side milling a bit differently. So if I go to side milling, right? If I pick on this face here, notice this face goes all the way down to there. So it's really going to machine down at that altitude. I want to machine at this altitude. So I could choose this edge. That is a local edge. I want to machine on this side. Pretty cool. If I choose the edge though, I have to compensate for the radius. Okay? Not the end of the world, but I also want to go all the way around the part. So instead of using that edge, I'm going to use this edge. Again, material side when you're choosing edges is important. And then altitudes. So I can go to here and I can say for my machining altitude, I'm not machining to where that edge is. I'm machining down to where this edge is. And done. Now, something interesting. If I look at this, you notice how this tool path is trimmed up over here. It's because this fillet, the way it comes out, you know, sometimes when models get trimmed and everything, the fillets kind of take a beating. So the software is confused. It thinks it doesn't fit there. So to be safe, it's pulling out long before. Okay? But you can come back into here and say, you know what? Don't check the finished part. I know it's okay, and I have a tolerance on my fillet, so go ahead and put that tool path in down there. Finally, notice my lead in lead outs. Per altitude, they're nice and tight, nice and close. When we get down to here, notice it extended the lead in lead out so that your plunge is actually off the part. And it's off the part by the cutting area of the tool. The radius isn't cutting there. Again, TopSolid pays attention to everything. Click OK. Tool path done. So hopefully you guys are getting the idea of what you can do here. Now, the last thing I want to talk about, we'll end this in just a few minutes. If you have questions, maybe start thinking of them, typing them into the questions bar, is how can we further reuse machining strategies? Well, I can take this facing, for example, because we really like that facing, and I can come up here to my favorites. And I can enter this and say simple facing and hit save. And here it's going to say, do you want to save it with the tool? I'm going to say, sure, I like it with that tool. With the cutting conditions? Absolutely. Only for the current machine? Nah, all machines. And now I have something called simple facing. And the way that will work, just to show you, let's go into another project here and let's import another file really quick. We're going to go import file with conversion. And let's do just basic part. Why not? Let's send the basic part, looks like that, into machining. It can be a completely different machine. Doesn't even matter. Okay. This is going to be on a Haas with a 4-axis trunnion, or 5-axis trunnion, pardon me. Let's pop it right there, and just for sake of time, let's say that's good enough. And this is on the table. And now I want to go here, and I want to go to end milling. I can go here and choose my simple facing, which now applied those exact settings, that tool and everything to the part. And like that, I'm programming very, very efficiently and very, very quickly. So that pretty much brings us to a wrap on this webinar for job shop style programming. Hopefully everyone in attendance was able to get something out of this. If there's any questions at this time, I'm happy to answer them. Otherwise, thank you for your time and have a great afternoon. Any questions? Okay. Have a great day, everyone.